Hello, Nines. We'll just do a quick review of some things that we talked about last year. So last year in our unit on mechanical systems, we talked about energy and how it can change forms. We looked at how energy can change forms from maybe, let's say, mechanical to kinetic, the energy of motion, or gravitational potential energy, and chemical energy, and light as energy. And we looked at all these, or sound energy, and we looked at all these different forms of energy and how they seem to and how they do change from one form to another's. We can't really lose energy. It doesn't go anywhere. It just changes forms. Thermal energy is another one that we discussed last year. We also looked at how machines aren't always, they can never be 100% efficient because some energy can be lost as thermal energy, as heat or sound or even light. And so we are talking about a very similar topic in grade 9 as well, except we just have a huge focus on electricity because that's what our unit is about. So electrical energy is for sure a type of form that can be converted into something else, which is great for us, so that we can so we can harness that electricity in our everyday lives to make our lives easier and better. And also we want to acquire this type of electrical energy as well, so we can send it to our homes. So whether we're using thermal energy or some other different types that we're going to discuss in this topic, so that we can get it, so that we can use it. So the energy connection. So energy, like we just talked about, appears in many forms. And we don't really create, well, it can't be created out of nothing, and but we can convert it, we can change it from one form to another. So the first type that we're going to talk about is heat. So we can, you might remember this from our topic on incandescent light bulbs last year, and how if we went, or even like a few topics ago, when electrons are run through a material in which there's a little bit of resistance, or whenever there's resistance, some of those electrons are going to give off some of their energy as heat. But in some cases that can be really useful, and so if we can have that resistive coil in a hair dryer, or that highly resistive material, we can use it in something like an oven as well, because we need to cook our food, got to get that hair dry. That's important too. In some places they even have electric furnaces, so where we just have air blowing over a heated coil, and you can, some people, not in Alberta a lot, but some people do heat their homes that way as well. So oppositely, so we can go from, this is talking about going from electricity to heat, which is used in these devices. We can also go from heat to electricity in something called a thermocouple. So to do this, you need two different wires made up of two different types of metals. So you're going to get these two wires, you're going to wind them at these junction points, whoa, and if there's a temperature difference between these two junction points, current will begin to flow. And so we got a candle here, and we just have this reference junction here, which just means, I don't know, at room temperature or at a constant amount. But if there's a temperature difference, current will begin to flow. And why I say either like some measurable number or some temperature that we know, because in many cases thermocouples are a tool used to measure temperature. So if we know the temperature of this point, if we can keep that constant, basically what happens is the bigger the temperature difference, the more current will flow. And so we can use that as a sense of, well, basically, if we have this temperature difference, if we can see a number on this ammeter, if we can see that as that increases, that tells us if we have a big number here, we have a big temperature. If we have a small number, we have a small temperature. And so these are very good devices for measuring extremely high temperatures. And maybe by extremely high, I mean, it might mean like into the hundreds or something like that, where we can't use one of those liquid thermometers because, yeah, those are maybe going to 100 or 120 in those alcohol-based thermometers. They can't go super high. But with something like this, since it's made out of metal, yeah, as long as, I guess we could measure up to the melting point of the metal, which in some cases is pretty high. And so that's, yeah, one big use for them. The piezoelectric effect. So piezo in Greek means pressure or push. And so what we see is if a current is applied to certain types of materials, like a quartz crystal, these crystals are going to vibrate, or there's going to be a little push on them when if they're connected to like a battery or something. So we see these commonly used in like talking greeting cards. And so my father-in-law still has one from 20 years ago, the Charlie Brown one, where you open it up and like sings a song. And so, yeah, this is where they're common. This is one place that they're commonly seen, because you can make a tiny little speaker as long as you have a little battery, and all it takes is a crystal attached to some other material that that can produce some sound waves. Oppositely, if we apply pressure, if we can use like, I don't know, maybe some mechanical energy, or if we can use something like this, if we can put pressure on that same crystal or that same type of material, we can create a current. So this is used in something like a barbecue lighter, where we apply pressure to that crystal, and then if that crystal is connected to a circuit, we get some current flowing, and so that's how these devices can make a spark. Electricity to light. Yeah, we need light. We need light to read at night. We need light to come off those TVs and computer screens so we can be entertained, I guess. And so, last year we talked about a lot of different types of ways we can get light. Incandescent bulbs, not really used that much anymore, but current that is being run through material such as like tungsten heats up, and when it gets hot enough, it will eventually turn into light. We looked at fluorescent light bulbs as well, and one that we didn't really talk about too much last year, but it's like a lot more common these days, and so these are the types of bulbs now being sold in hardware stores, and rightly so. But if we have there's I guess we can think of materials that conduct electricity in three ways, and we talked about two of them a little bit already. So materials that can conduct electricity very well, these are our conductors. Materials where electrons don't flow through quite as easily, these are called insulators. But there's this in-between material called semiconductors. And if you can take two different types of semiconductors, I guess they're called this is beyond the scope of this course, but an N-type and a P-type, and one of those types will contain some electrons that can move. But you basically got to take these two different types of conductors and you put them together. And since there's two of them, we know one of the prefixes for two is di, so we can make these diodes. And this is what LEDs are called, these light-emitting diodes, these two different semiconductors put together. And if we can run a current through them, electrons will move from one to the other, and they lose a little bit of energy and give off a photon, or they give off a little bit of light when a current is run through them. Another interesting fact about them is that they only work in one direction, so we got to make sure that they're plugged in right. And oppositely, so we've gone from electricity to light. We can also go from light to electricity in a photovoltaic cell. So very similar to LED lights, you need those two types of semiconductors made with different type. Well, silicone is a huge component of photovoltaic cells. And so, but mixed with other materials, you can make these, again, two types of semiconductors, put them together, and when light hits these materials, the electrons begin to move, connect them to a circuit, and we can get electricity from light as well. And so I'm going to be talking more about this in the coming days, but I think that's good enough for now, and yeah, take care.